In week 2, our focus is on matrices and using matrices to solve systems of equations. Before we do that, though, I want to give you a basic introduction to what we're going to be doing with matrices. So we've already solved systems using elimination, and so what a matrix does is it organizes this process. If you think about it, when we're solving a system, we don't really care about the individual variables. We actually only care about the coefficients, the numbers in front of the variables. So a matrix organizes this. Another way to view a matrix is simply as an array of numbers, but in our case, it's going to represent those coefficients. And an augmented matrix will represent not only the coefficients, but the constants on the right-hand side of the equation. We can refer to elements. We always go in order of row column, and I'll show you that in a second. And then we'll solve systems using row operations, which is another topic altogether. So really what I want you to understand is just the idea in this video of setting up systems of equations into a matrix, using an augmented matrix for that. So right here I have an example of a system of equations, and so sometimes these will be in terms of x's, sometimes in terms of several variables. It all depends on the situation. So an augmented matrix takes each column and uses that to represent the coefficients for one particular variable. So for example, one column would be the x's, one column would be the y's, one column would be the z's. And each row will represent the complete equation. Augmented means that you include the constants on the right-hand side. So for example, I'll take the first equation, I'll put 1, 1, 2, 12. So that's the first equation. And again, I'll keep doing this. And because this is already in order where we have lined up the x's, y's, and z's, I can just write straight across. But you do want to make sure in any given column it's one variable represented. If a variable is missing for some reason, then what you'll do is we'll put a 0 there. Now most of the time, though not all the time, little inconsistencies sometimes, we'll put a line here to represent augmented, but other times you'll be just told it's an augmented matrix. So this would actually be the augmented matrix for this system of equations. This is what we'll use to solve the system. Now what about this idea of a coefficient matrix? Coefficient matrix just includes the coefficients, so actually it's just this portion of the matrix. This doesn't matter just yet, but in our next sections next week, this will actually be important. The distinction matters. And so you should know the terminology. So notice the difference. It doesn't include the coefficient or the constants on the right-hand side. It includes only the coefficients. So coefficient matrix is going to be this portion of a system of equations. Now, what about referring to the elements inside of a matrix? Well, if I was to say, for example, what is the 2, 2 element of this matrix right here? So let's call this matrix A. So the 2, 2 element in this particular case would be second row, second column. So second row, second column, that would be 3. Or I could also refer to this as A22. So as another example, what is A31? So that would mean the third row, first column, that would be the -3. So that would be -3. And I could also refer to that as 3, 1 element. So this is just the basic terminology you should have when working with matrices. And so after this, then we'll talk about row operations.